Okay, so in this video I'm going to show you how to work with a capacitor, how to charge it, discharge it, how to build the circuit and all those important stuff, how to make measurements. Now you guys are familiar with the board, you have seen this before. The batteries over here and the connections, the positive side, the negative side of the batteries, the switch, can flip it to either side, the three resistors, this is the 10 ohm resistor, the 33 ohm resistor and the 100 ohm resistor, the three light bulbs, and here the capacitor. This is a 1 farad capacitor, and this particular capacitor has a polarity, the positive side here, the negative side here, and using these wires we can make all the connections we need. And again, the bottom side of most of these components are connected, so all these connected to this metal connection here. What else? So that's about the board, the connecting wires and the meter to measure voltage, current and resistance. Okay, so the first part is, let's see, how to figure out whether a capacitor has any charges in it, whether the capacitor is charged, fully charged, partially charged, whether there's any voltage in it. So to check a capacitor, what we do is we take the meter, put it to voltage side, and if nothing's connected, it shows it kind of, the numbers are changing at the millivolt range. If nothing's connected, it says millivolts here. You won't be able to read that, this little thing MV, that means there's nothing. So we take the probes, hold on, there's a lot of wires around here. So we take the probes, here's the two probes, we place them on either side of the capacitor, across the capacitor, one to the positive, one to the negative, and right now it shows 2.92. so this capacitor has some voltage in it, means it has some charges in it. So that means we can use it for something, right? Like light up a light bulb or something. So how do we do that? I'll show you how to use the capacitor. Take two wires. I'm going to light up this one, so one end I put here, the other end take another wire, the second wire over here, and take this wire away. And we know that the other end of the light bulb is connected through this line, goes all the way here. So if I place it over here, see, it lights up. So initially it was very bright, now there's nothing. You saw that it decreased over time. So I'm using the capacitor, I'm draining the capacitor through this light bulb, right? So the energy in the capacitor, the charges in the capacitor transform into current used in the light bulb. Okay, so let's check the capacitor again, see what we have. Take the meter, put it across. Now we see 24, 26. It's going up, that's normal. Capacitors sometimes accumulate small charges from the environment. These are all millivolts, right? It's really nothing. It can go up to some, if I hold it long enough, it might go to maybe like a fraction of a volt, but mostly this capacitor is discharged, so mostly it's empty. Okay, so so that is part 1, right? How to check the voltage of the capacitor. So let me write down the time here, something real quick. Alright, so next thing I want to do is we're going to charge a capacitor. How to charge it? Now we're charging it through the light bulb, right? So we're going to use this light bulb over here. So we will use the battery. Let's see how much voltage we have in the battery. So use the voltmeter, take the 2 leads, put it across. The battery has a voltage of 2.92 volts. Okay, so that's the battery voltage. How do we charge this? So we'll have one wire coming from the battery, and I want the capacitor to be charged through the light bulb. So I'm going to do it this way. I'm going to put it over here, right? So when I connect the switch, when I flip the switch to this side, the current comes from the battery, goes here, goes through this switch, comes over here. It's available through this line, so I'm going to use this bulb. So the other end of the bulb, I'm going to put it to the capacitor. I'm going to keep the switch on, open, put it here, and then it's the positive side of the capacitor. The negative, I take it and I put it to the other side of the battery. Alright, now watch carefully. Don't pay attention to the meter. We're not measuring anything with the meter. Look at the bulb. I'm going to flip it to the on position. See how the brightness is changing. There's nothing right now. I flip the switch. You see it's really bright and it's decreasing. Brightness is decreasing, still connected, right? This was initially it was an empty capacitor connected to the battery. We are trying to charge it through the bulb. Initially lot of light, it was bright, and the brightness decreased. Now there's nothing. Let's see what the voltage across the capacitor. So I take this, I'm going to place it across the capacitor like this. I see 2.91. That's pretty close to the battery voltage. So it's kind of trying to go to 2.92 while we are watching, right? Now what's the battery voltage? 2.92. So the capacitor is fully charged. Right? It has the same battery voltage almost. Okay, so that's that. Alright, so we have a charged capacitor. So let's check the voltage of the capacitor one more time. Looks like 2.92. So I'm going to take all the wires off. I'm going to open the switch. I'm going to take wires off. So let's check the capacitor one more time. 2.92, so it's holding the charge. It's a storage unit, so it has the charge. Now I want to build a circuit to discharge the capacitor, use it. You already saw it little earlier, but let's build this one more time. So I want to discharge it, use the capacitor to I'm going to use it with this light bulb over here. So how am I going to do that? So I will say positive side. If I want to use the switch, I'm going to put it here, and then when I flip the switch, I know that current comes here, here, all the way here, and then the other side of the bulb should go back to the capacitor. Okay, our circuit is ready. Let's check the voltage one more time, see what we have in this capacitor. We have 2.9. It was 2.92, so it has dropped a little bit. Ideal capacitors can hold the charge for long period of time. Here this is not ideal. This capacitor is old, and also through atmosphere it can leak a little bit. So anyways, we still have 2.9, pretty close. So watch the bulb. We're going to turn the switch. We're going to connect it. There we go. It was bright in the beginning, decreasing, becomes nothing. Almost zero, gone. Let's check the voltage. It's dropping. It's millivolts, and it's dropping fast. It was dropping fast. Now it's not dropping that fast. 1.7 millivolts, 1.6, 1.5, 1.4. Anyways, the idea is it's decreasing. Okay. Alright, so next thing, we're gonna charge the capacitor again, but this time we'll be taking some we'll monitor how the voltage is changing. Now it's the same circuit again, right? Battery, the positive current comes here, the switch all the way here, the light bulb, and to the capacitor, and the negative side of the capacitor back to the battery. So what I have is the charging circuit. I have connected the meter in either side of the capacitor, the black lead and the red lead over here, the two probes. So I just connected them so that I don't have to hold them. So right now the capacitor shouldn't have much charge in it. You can see it's 46.2, 46 some millivolts in it, right? It's millivolts. Alright, so we're gonna flip the switch. Watch carefully. You remember, you're gonna see a lot of brightness, and then it decreases. I want you to pay attention to this, right? The meter reading. See what happens. I'm gonna flip the switch. 1, 2, 3. It's going up, right? 1.5, 1.6. These are volts, not millivolts. Went to 2. It's increasing. Let's see, now it was increasing fast. Now it slows down. Now if we wait long enough, it's 2.9, it's 2.91. If we wait long enough, it will reach 2.92. It will reach battery voltage eventually. Okay? Alright, not gonna wait that long. Alright, let's build the discharging circuit. So I took that wire off, the red wire that was here. Now, the meter still attached. You can see the voltage of the capacitor 2.9. I'm gonna discharge it through this bulb. So positive side comes to the bulb, and the other side of the bulb goes over here. So I'm gonna take the negative side. Let's keep the switch to the other direction. I'm going to take the negative side of the bulb. I'm going to put it over here. Okay, so positive current comes out from this yellow color wire, comes here through the bulb. once I flip the switch, goes back to the capacitor. So we have a continuous circuit. Right now we have 2.88 volts in the capacitor. Let's flip the switch. Pay attention to this. You remember it's going to be bright earlier. It's going to be brighter first and then it's going to decrease. But let's look what happened here. Dropping fast, brightness decreasing, and 0.5 volts, 0.3 volts. Now switch to millivolts. So going at millivolts. Now you see actually it's millivolts changing, right? Earlier volts were changing, now millivolts, and that also slows down a lot. Slowly changing, decreasing millivolts very slowly, small amounts of voltage changing with time. Now again, if we stay long enough, you'll see this drops to 0. It is going that way. Let's stop right here. Alright, so this is the final circuit. Now it looks complicated here on the board. This is to charge and discharge at the same time, means without changing the wires. Just by flipping the switch into either side, I can charge it if I go this way, I can discharge it if I go this way, right? So capacitor is almost empty. I'm going to put it to discharge side and bring it all the way to fraction of a millivolt. So capacitor is mostly empty. This is like 0.3 millivolts. When I flip the switch to the other side, it's going to charge. The diagram, you already draw the diagram. Connecting wires, it's a little difficult to explain on the board. So have it here. Look at the voltage. You can see what happens with the bulb. Charging, voltage going up. It jumps into big values in the beginning and then it slows down. So that is the most important thing here. It takes time to reach the highest, the maximum voltage, right? Alright, so we're going to flip it to the other side. We're going to discharge it. Now it's discharging. Initially the voltage dropping fast, and it jumps to millivolts. So when the voltage is small in the capacitor, it takes longer time for it to completely come to 0. It slows down. Okay,